Imagine a force so powerful it could wipe out entire cities, cause tsunamis, and even trigger a mini ice age. This isn't a plot from a Hollywood blockbuster, but the real, devastating potential of a significant asteroid impact. The immediate aftermath could see fires raging across continents, while the debris thrown into the atmosphere could block out the sun, leading to a chilling long-term winter. To put this into perspective, let's travel back in time to the late Cretaceous period, some 66 million years ago. A massive asteroid, around 9 miles in diameter, struck what is now the Yucatan Peninsula in Mexico. The cataclysmic event is believed to have led to the extinction of the dinosaurs and most life on Earth. Such an impact today would be catastrophic to say the least, but don't pack your bags for Mars just yet. Humanity has some tricks up its sleeve. Starting at number 10, we have enhanced ground-based telescopes. These stalwart sentinels of the sky play a pivotal role in the detection and tracking of near-Earth objects. With their ever-watchful gaze, they help us identify potentially hazardous asteroids long before they pose a threat to our planet. Their main advantage lies in their accessibility. Ground-based telescopes are relatively easy to build, operate, and maintain. They are our first line of defense, providing us with a wealth of data about the cosmic neighborhood we inhabit. However, they do have their limitations. Atmospheric interference and daylight can greatly limit their observational capabilities. Also, they can only survey a fraction of the sky at any given time, leaving potential blind spots. Despite these drawbacks, the role of ground-based telescopes in planetary defense cannot be overstated. They are the proverbial canary in the coal mine, sounding an early warning of any impending danger. While this method is crucial, it's just the first line of defense. Next up at number 9 are space-based infrared telescopes. These ingenious devices are our eyes in the sky, constantly scanning the cosmos for any signs of potential danger. Unlike their ground-based counterparts, these telescopes are not hindered by atmospheric distortion or daylight, allowing them to provide a continuous, clear view of space. They're especially adept at detecting asteroids due to the heat they emit. You see, asteroids are warmed by the sun, and this warmth makes them shine brightly in the infrared spectrum. It's like they're waving a big cosmic flag saying, "Here I am." Currently, initiatives like NASA's Near-Earth Object Observations program are utilizing these telescopes to detect, track, and characterize potential hazardous asteroids and comets that could impact the Earth. However, it's important to remember, while these telescopes increase our detection abilities, they can't stop an asteroid. For that, we'll need more than just a good pair of eyes in the sky. At number 8, we have international collaboration. When it comes to defending our planet, no nation can stand alone. The vastness of space and the unpredictable nature of asteroids require a global effort. International collaboration is not just a lofty ideal, it's a necessity. Existing initiatives like the International Asteroid Warning Network and the Space Mission Planning Advisory Group are shining examples of how countries can come together for a common cause. These organizations coordinate efforts, share data, and jointly plan for potential asteroid threats. Moreover, the United Nations has endorsed guidelines for planetary defense, bringing an unprecedented level of global commitment to this critical issue. This kind of cooperation ensures that all nations, regardless of their technological prowess, have a say in our collective defense. In the grand scheme of things, borders dissolve when viewed from space. Our survival hinges on our ability to work together. United we stand, divided we fall to space rocks. Coming in at number 7 are robotic mining missions. These missions are the next big step in our asteroid defense strategy. Picture this, a fleet of robots sent into the cold void of space, equipped with the capability to mine asteroids. Not only does this open up a universe of resources for us, but it also gives us a means to alter the trajectory of these celestial bodies. By systematically chipping away at an asteroid, we can change its course, effectively steering it away from Earth. However, this method is not without its challenges. The technicalities involved in sending robots to mine asteroids are immense. We're talking about navigating vast distances, dealing with extreme conditions, and managing the complex operation of mining in zero gravity. It's a monumental task that requires significant advancements in robotics and space travel technology. As promising as this sounds, it's still a work in progress. But with the rapid pace of our technological evolution, it's a future that doesn't seem too far off. Halfway through our countdown at number 6 is Kinetic Impact Deflection. This method is akin to a cosmic game of billiards where we use a high-speed spacecraft to nudge an asteroid off its catastrophic course. The idea is simple, but the execution is anything but. The objective is to hit an asteroid with enough force to slightly alter its trajectory, not shatter it into a million pieces. This is where the concept of kinetic energy comes into play. The spacecraft doesn't need to be large, but it does need to be fast. The faster it is, the more kinetic energy it carries and the greater the deflection it can cause. NASA's DART mission, the Double Asteroid Redirection Test, is a perfect example of this strategy in action. It's set to demonstrate the kinetic impact deflection technique on a non-threatening asteroid. This method is more about finesse than brute force. Number 5 on our list is the gravity tractor. This ingenious method utilizes a spacecraft's own gravitational pull to slowly nudge an asteroid off its destructive path. Picture it this way. The spacecraft hovers near the asteroid, and over time, the mutual gravitational attraction between the two bodies causes the asteroid to alter its trajectory. This strategy has several key advantages. Firstly, it's a non-contact method, meaning the spacecraft doesn't have to physically touch the asteroid to alter its course. Secondly, it allows for precise course corrections, crucial when dealing with objects hurtling through space at breakneck speeds. However, the gravity tractor does have its limitations. It's a slow process, requiring months or even years to make a significant difference. Also, it's not as effective on larger asteroids due to their greater mass and gravitational pull. Despite these challenges, the gravity tractor is a slow but steady solution. At number 4, we have the nuclear explosion method. Now this might sound like something straight out of a sci-fi movie, but it's a concept that's been seriously considered. The idea here is to use a nuclear explosion to either deflect or disintegrate an approaching asteroid. Imagine this: a spacecraft carrying a nuclear device is launched towards the asteroid. Upon reaching a close proximity, the device is detonated. The immense force of the explosion would either push the asteroid off its earthbound trajectory or shatter it into smaller pieces that would burn up in our atmosphere. However, this method is not without its risks. The fragmentation of the asteroid could potentially create multiple threats instead of just one. And then there's the matter of international regulations. The use of nuclear weapons in space is a contentious issue, governed by various international treaties and agreements. Talk about a blast from the past. Third on our list is laser ablation. Now this sounds like something straight out of a sci-fi movie, doesn't it? Well, it's not as far-fetched as you might think. Laser ablation is a fascinating concept that involves using powerful lasers to vaporize parts of an asteroid. This process creates a force like a jet engine, propelling the asteroid off course and away from our beloved planet. However, there are some significant technical challenges to overcome. For starters, we need a laser powerful enough to reach an asteroid in space and cause significant damage. Then there's the question of accuracy. We can't just fire lasers willy-nilly into the cosmos. We need pinpoint precision to ensure the asteroid changes course in the right direction. Despite these challenges, the potential of laser ablation is immense. With advancements in technology and our growing understanding of space, we're inching closer to turning this science fiction concept into reality. This method is still in the realm of science fiction, but it's getting closer every day. Coming in at number 2 is the mass driver. Now, this is a unique concept that involves using a device right on the asteroid itself. The device, known as a mass driver, works by ejecting material from the asteroid. This action results in an equal and opposite reaction, courtesy of Newton's third law, and it's this reaction that can alter the asteroid's trajectory. Imagine it as a sort of space-age slingshot. The asteroid's harmful heading is tweaked, nudging it off a collision course with our beloved Earth. The beauty of the mass driver lies in its simplicity and the fact that it doesn't require any additional propulsion system. However, it's not without its challenges. Precision is key, and it demands a thorough understanding of the asteroid's composition for effective implementation. There's also the hurdle of landing and setting up the device on a tumbling, spinning mass of rock and metal in the first place. This is a more hands-on approach to asteroid deflection. And finally, at number 1, we have asteroid capture and utilization. Imagine this: a celestial body floating in the vast expanse of space, teeming with raw materials, metals, water, and even fuel. Now picture us humans harnessing this bounty not just for scientific research, but for the survival and advancement of our species. This is the concept of asteroid capture and utilization, an audacious idea that's as fascinating as it is complex. The first step is to capture an asteroid, a task that requires a delicate balance of precision and power. Spacecraft equipped with advanced robotics and propulsion systems would rendezvous with the asteroid, slowly altering its trajectory to guide it into a stable orbit around the Earth or the Moon. This process, though challenging, holds immense potential for our understanding of the universe. Once we've secured the asteroid, we can begin to mine its resources. We're not just talking about precious metals like platinum or gold, although those are certainly on the menu. More crucially, asteroids could provide water, which can be split into hydrogen and oxygen, the basic ingredients of rocket fuel. Think about it, a fuel station in space, a pit stop for interplanetary missions. But the promise of asteroid capture and utilization extends beyond resource extraction. It's also about long-term planetary defense. By studying these ancient bodies up close, we can gain insight into their composition, structure, and behavior. This knowledge could prove invaluable in devising strategies to deflect or destroy potential Earth-bound asteroids. Moreover, if we can master the art of manipulating asteroid orbits, we could potentially use them as shields, redirecting them to collide with incoming threats, turning a potential danger into a line of defense. So, as we gaze into the cosmos, let's remember that the asteroids whizzing around our solar system aren't just celestial threats. They could be the keys to our future, brimming with resources and potential solutions to some of our greatest challenges. In the fight against asteroids, our best weapon might be the asteroids themselves. So there you have it, the top 10 space-based solutions for planetary defense. From the ground and space-based telescopes keeping an eye on near-Earth objects, to the international collaboration pooling resources and knowledge, we're building a comprehensive defense system. Robotic mining missions are not only exploring the potential for resource extraction but also aiding in our defense strategies. Meanwhile, kinetic impact deflection, gravity tractors, and nuclear explosions offer different methods for changing an asteroid's course. Laser ablation and mass drivers might sound like they're straight out of science fiction, but they're very real technologies in development. And finally, asteroid capture and utilization, turning a potential threat into a resource. Each solution carries its own potential impact, its own promise for the future of our planet. Remember, the best way to deal with a catastrophic asteroid impact is to prevent it from happening in the first place. As we've seen, the defense of our planet from potential asteroid impacts is a complex and multifaceted endeavor, but you too can play a part in this grand mission. How? By educating yourself and others. If you learned something new in this video, give it a like. If you have thoughts or opinions about any of the solutions we discussed, share them in the comments section below. We learn from each other and your input is valuable. Don't forget to subscribe and hit the bell icon to stay updated on more fascinating topics like this. Knowledge is power, and by sharing this video with your friends and family, you're contributing to a more informed, more prepared society. Remember, the best defense is a good offense, and in this case, that offense is knowledge and preparedness. So, let's keep the conversation going, let's keep learning, and let's keep our planet safe. Together we can turn potential threats into promising opportunities. Until next time, stay curious, stay vigilant, and as always, stay fascinated by the wonders of our universe.